Welcome to Naradar Academy. In this video, we are going to discuss about moment of a force. Let us consider a force F which is acting along the line AB and let O be a fixed point. Okay, and this ON is a perpendicular drawn from O to the line of action of F. Let the length of this ON be equal to P. Then the product of the force and its perpendicular distance F into P is called the moment of F about O. Okay, so what is moment? The force into its perpendicular distance. Okay, this point we can choose randomly. So here I have taken O. So moment of F about this O is given by F into P. Okay, then when will you have zero moment? So the moment of a force becomes zero in two different cases. One is the force itself is zero. Okay, so if the force is zero, then the product of force and its perpendicular distance will be zero. The another one is this point, no, with reference to one point we are finding the moment, no, if this point itself is lying on the line of action. If this O is lying on the line AB, in that case the perpendicular distance will be what? Zero. In that case also what we get? The moment as zero. So these are the two different cases where we will get zero moment. Okay, then next one is this moment is expressed in terms of area of a triangle. That is this is called geometrical representation of moment of a force. Suppose if I have a force whose length and line of action are represented in magnitude, direction and line of action by AB. Okay, that is this AB represent the force F both in magnitude, direction as well as the line of action. If everything is represented in terms of this line AB and O is the point with reference to which we are calculating the moment, then you complete this triangle OAB. Okay, then moment of the force is given by 2 times area of the triangle AOB. Okay, so this way also we can find out the moment. Next one is sign of the moment. Moment is a vector quantity, no? So it will have either positive or negative sign depending on the direction in which it rotates the body. Okay, if it rotates the body in anti-clockwise, it is positive, and if in clockwise, it is negative. So this is the usual procedure that we follow in mathematics. So for every anti-clockwise direction, we take it as positive, and for clockwise, we take it as negative. But simply, how can we write the sign of the moment? See, suppose, let us take this case. Whenever you want to find whether it is rotating clockwise or anti-clockwise, if you are not sure, you walk along the force, okay, along the line of action, along the direction. See, that is you start from A and you walk along this AB. Towards B you walk. That is the direction of the force, no? Okay, on which direction you are getting this O? On your left side, no? Left hand side. Can you understand? That is, you start walking from A, you move towards B because that is the direction of the force, no? Your point of reference is lying on your left hand side, no? If it is lying on your left hand side, then the moment is taken to be positive. Suppose if you want to find the moment of the same force with reference to another point O dash on lying on this side, then this O dash will be lying on your right hand side, no? So if it is on right hand side, the moment has to be taken as negative. Okay, so walk along the direction of the force along the line of action. If the point of reference is lying on the left hand side, moment is positive. If it is on right hand side, the moment is negative. Okay, then another one is Varignon's theorem on moments. Here the statement of this theorem is, suppose if we have two forces acting at a point, okay, then there will be a resultant, no? So one side we have two forces, on the other side we have the resultant. Then you take moment of the resultant about a particular point, and at the same time you take the moment of the algebraic sum of the moments of the two forces about the same point. Then the two will be equal. That is the algebraic sum of moments of two forces. If I have two forces P and Q, then algebraic sum of moments of P and Q will be equal to moment of the resultant R. Okay, about the same point, right? So this is called Varignon's theorem on moments. Now let's see two problems based on moments. The resultant of three forces PQ are acting along sides BC, CA and AB of a triangle ABC. So we have three forces acting along the sides of a triangle. and the resultant of these three forces passes through the orthocenter. Okay, what do you mean by orthocenter? That is, orthocenter is the line of intersection of, okay, perpendiculars drop from the opposite vertex. That is, from A you drop a perpendicular to BC, from B you drop a perpendicular to AC, and C you drop a perpendicular to AB. Then the line of intersection of all these three lines is called your orthocenter. So in this question, what they have given is, I have three forces, one is P, another one is Q, another one is R, which are acting along the sides of a triangle, and the resultant of these three forces will be there, no, that is passing through your orthocenter. What is the result we want to prove? The triangle must be obtuse angled. Okay, this is the first result, and the second result we want to have prove is, in case if angle A equal to 120 and if angle B and C are equal, okay, in this case Q plus R equal to P root 3. So two results we want to prove. Okay, right. So I have taken a triangle ABC. So P is acting along BC and Q is acting along CA and R is acting along AB. Now it is given in the question that the resultant of these three forces is passing through the orthocenter. So let me draw the orthocenter. Drop a perpendicular AD. This is perpendicular to BC, and from B you drop a perpendicular BE, which is perpendicular to what? AC. And similarly CF perpendicular to AB. Now all these three lines meet at O. No, this O is called the orthocenter. Okay, right. Now this problem I am going to solve with the help of moments. Okay, in statics already we have uploaded three videos. Okay, one is based on parallelogram law, triangle law, Lam's theorem. The another one is based on resolved parts of a force, and the third one is about parallel forces. Okay, so if a problem in mechanics is given to you, you can solve the problem in different ways. Okay, this problem now I am going to solve by using the concept of moment of a force. Okay, now they have given the question that the resultant of the three forces is passing through this O. That means the moment of all the forces, okay, algebraic sum of the moment of all the forces taken about this orthocenter will be equal to 0, because the body is in equilibrium, no. So the moment of P plus moment of Q plus moment of R taken about this particular O is equal to 0. Why it is equal to 0 means, because the resultant of the three forces is said to pass through O, no. So what do you studied in the previous case? That is, when you will have zero moment, two different cases. First one is when the force itself is 0, another one is when the point is lying on the line of action. The second concept I am making use of here. Here the resultant of the three forces is passing through O. Therefore algebra, and I am making use of the Varignon's theorem also. Therefore algebraic sum of moments of all the forces is equal to moment of the resultant. But the resultant is passing through O, no. So their value is equal to what? 0. This concept I am making use here. So first let us see what is the moment of P about O. See, this is my P, no. So P into perpendicular distance from O to P. This is the perpendicular only, no. So what is the perpendicular distance? OD. So P into OD. What about the sign of moment? See, you walk along P, along this direction, along this line. This O is lying on your left hand side, no. Therefore P into OD is positive. Okay, next one is for Q. Q into OE. The perpendicular distance is what? OE. In the same way, you walk along Q in this line of action along this direction. Then this O is lying on your left hand side, no? Therefore Q is also what? Positive moment. And similarly for R. R into OF. You walk along this AB. Then this O again same thing lying on the left hand side. Therefore R into OF is also positive. So algebraic sum of all these moments is equal to moment of their resultant about O. But since the resultant is passing through O, what? Its value is equal to 0. So this is equal to 0. Now I have to make some, that is I have to find the values of this OD, OE and OF and substitute it here. Okay. So for that, see, look at this triangle. Bigger triangle is there, no? BCE. This is there, no? That is now what is my purpose? If I find OD, that is enough for me. From there I can write the values of OE and OF. So I want to find OD. So I am looking at this triangle. See this triangle. This is 90 degree, no? And this is angle C. So this angle will be what? 90 minus C. Okay. So tan of 90 minus C equal to, okay, this angle is 90 minus C. From this bigger triangle I have taken. Then after that you consider this smaller triangle, because only OD only I want to find. So when you consider this smaller triangle, tan of 90 minus c equal to what? Opposite side by adjacent side, no? So OD by BD. Okay, what is tan of 90 minus c? Cot c. Cot c is equal to OD by BD, or OD equal to BD cot c. Okay, right. Now we want to find what is BD. So for finding this BD, let me consider again this bigger triangle. BD is the part of this bigger triangle, no? So from here, what is cos B? Cos B equal to BD by AB. So what can I write? BD equal to AB cos B into cot C. Okay, but in mechanics already I told you, whenever you are taking a triangle ABC, this is vertex A, no? So the opposite side is of length small a. If this is B and this is of length small b, if this is C and this is of length small c. So instead of this AB, what can you write? AB is here only, no? So this is of length C. C cos B into cot C can be written as cos C by sin C. So C by sin C into cos B cos C. But here this O is the orthocenter, no? For orthocenter we have a result C by sin C equal to B by sin B equal to A by sin A equal to radius of the orthocenter. Okay, sorry, radius of the circle. So here with O as center and we draw one circle, no? And that radius will be what? 2r dash. Right, r dash is the radius. So instead of the C sin C, I can write it as 2r dash. 2r dash cos B cos C. So I find what is the value of OD. In the same way, you can write it for OE and OF. Okay, so OE will be what? 2r dash cos C cos B, and OF equal to 2r dash cos A cos B. Substitute all these results in equation number 1. So what you get? P, force P into 2r dash cos B cos C plus force Q into 2r dash cos C cos A plus force R into 2r dash cos A cos B equal to 0. Throughout you can cancel 2r dash and also divide throughout by cos A cos B cos C. Then P by cos A plus Q by cos B plus R by cos C equal to 0. This PQ are magnitudes of the forces, no? They will be positive only. But the algebraic sum is equal to 0 implies any one of them, any one of the cos values should be what? Negative. Okay, when will you have negative values for cos? Only in the second quadrant. Second quadrant means what? Obtuse angle. Okay, so the triangle must be obtuse angled. Okay, so any one of this angle must be obtuse angle, that is more than 90 degree. So the first part of the question is over. We have proved it is an obtuse angle triangle. For the second part, what is given? Angle A equal to 120, angle B equal to angle C. Okay, this is what given in the question. So if angle A is 120, the rest of the angle should be what? 30 degree only, because they have given in the question B and C are equal. So rest of the angle, sum of the rest of the angle should be 60 degree. Therefore each angle is 30 degree. So you substitute these values in this result. So P by cos 120 plus Q by cos 30 plus R by cos 30 equal to 0. So cos 120 is what? Cos of 90 plus 30, no? So it will be what? Minus sin 30. So minus 1 by 2 plus Q plus R by cos 30 is root 3 by 2 equal to 0. So by simplifying this result, we are getting Q plus R equal to P root 3. Okay. One more problem we'll see. A uniform circular plate is supported horizontally at 3 points ABC of its circumference. So I have a circular plate. It is supported. It is supported at 3 points. Okay, ABC of circumference. Show that the pressure on the supports are in the ratio. So on this, see, let W be the weight of this plate, which will be, this is a circular plate, no? So the weight of the circular plate will be acting at its midpoint. So let O be the center of the circular plate. So if the first force I am having here is the weight W, which is acting downwards. Okay. Next, this plate is supported at 3 points A, B, C, no? So at these 3 points, we will have the pressure or the normal reaction. Okay, because it is exerting weight on the 3 points, no? So they will in turn what? They will in turn have reaction. So let the reaction be R1, R2 and R3. They will be upward force. I couldn't represent it correctly here. So just like this I have represented, but they are all upward forces only. Weight is a downward force and these are all upward forces. So totally on this system I am having 4 forces. One is weight, which is acting downwards. Another one is reactions R1, R2 and R3. Right. Okay. Now let me draw a triangle joining the 3 points. The circular plate is here. Just for understanding purpose, I am completing this triangle ABC. Okay. Right. Now here also I am going to make use of the concept of moments. Right. Now you drop a perpendicular from A to BC, you drop a perpendicular AE, and from O you drop a perpendicular to BC. Okay, then I'm having one right angle triangle here, and this is the radius of the circle. OB is the radius of the circle. Now let me take it as R. Right, now I'm going to find the moments, but I'm not going to find the moment about a single point, about a line I'm going to take. So about BC, I'm going to find the moments about BC. Okay, the concept is the same. So what is the formula for moment? Force into its perpendicular distance. So we have to calculate the perpendicular distance about this line. Okay, why I am taking about this line BC instead of taking a single point? See, in the previous problem, okay, they have given that the resultant is passing through the orthocenter. So all the three forces have a resultant. That single resultant is passing through a point. So for me, it was convenient there to take moment about a single point. Okay, but here nothing is said about the resultant. So I have four forces which are acting at four distinct points. Our aim is we want to make zero as that is as much possible. Okay, so here if I take moment about a line BC, then moment of this R2 and R3, both of them will become zero. Only this R1 and the weight W alone I will be getting. Okay, so for that convenience only I am considering moment about this line, but the concept and all the same only. So this is BC, no? So consider this R1. What is the perpendicular distance of R1 from BC? For that purpose only I draw this line AE. So AE, so R1 into AE, and then so here you walk along this R1. This line is lying on right hand side, it seems. Okay, so I have taken it as negative, positive. Okay, so you can change the direction. That is actually it is in upward direction only. So when you don't imagine along this line, it is an upward direction. You walk along the upward direction. From A you walk along the upward direction. See, this is the reaction is here like this. If you start from A and walk along this upward direction, this BC will be lying on your left hand side, no? So R1 into AE. Okay, and then W is acting at O, which is acting downwards. So you start from O and you move towards downward side. On that case, your line of reference will be lying on your right hand side. So in that case, it has to be taken as negative. This is for understanding purpose only I have drawn. So this is actually, if you take along this line, you will be getting a wrong result only. This is our reaction. See, I am putting the pen like this, no? This is your reaction. So acting upward. So when you walk along the upward direction, this line BC will be lying on your left hand side. So this R1 into AE, this moment will be positive, and W is downward, no? When you walk along downward direction from O, it will be negative. Okay, the sum of these moments is equal to 0. Right, okay. What about R2 and R3? Their moments are 0 because they are acting along this line BC, no? So their perpendicular distance will be 0. Therefore, both the things vanish. Only these two results we have. So from this what I have? R equal to W into OD by AE. Now I want to find what is this OD and AE. Right? Now let us find AE. For finding this AE, consider this smaller triangle. So sin C equal to what? AE by AC. But AC is equal to C, no, small c. Therefore, AE equal to C sin C. So instead of this, what can I substitute? C sin C, and OD is equal to, sorry, B sin C. B sin C and OD. For finding this OD, consider this small triangle. Here, cos A. What is cos A? Cos A is equal to OD by this R. Okay, so what we get? OD equal to R cos A. So R1 equal to what I get? R cos A by sin C. But this is orthocenter only, no? So B by sin B equal to 2R. That implies B equal to 2R sin B. You substitute this value there. So R1 equal to WR cos A by 2R sin B sin C. Okay, right. Now, next, here this is my R1. From this I am going to write the generalized result for R2 and R3. So here I am having sin B and sin C, no? So if commonly I have sin A, sin B, sin C on the denominator for all R1, R2, R3, I can cancel the term, no? So for that purpose I am multiplying and dividing by sin A. Okay, multiply by sin A and divide by sin A. So here I am having W cos A sin A. Also you multiply and divide by 2. Already one 2 is there, no? Just for bringing the result in a prescribed form, I am doing all these things. Okay, your result is finished here itself. So 2W R cos A, R get cancelled. 2W cos A sin A by 4 sin A sin B sin C. This is 2 cos A sin A is nothing but sin 2A. by 4 sin A sin B sin C. This is my R1. In the same way, you can write the values for R2 and R3. Then you take the ratio. 4 sin A sin B sin C is common in all the three forces, no? So they all get cancelled, and W is also common factor which all get cancelled. So finally what you have? Sin 2A, sin 2B and sin 2C. Therefore the pressure on the 3 points ABC are in the ratio sin 2A, sin 2B and sin 2C. Okay, that's all. Thank you.